The operating system software sits on top of the hardware computing platform. At the base, we have the hardware platform itself, the CPU, memory, I/O devices. The hardware abstraction layer is low-level software that provides an abstraction on which higher layers can be built. The operating system kernel makes use of the hardware abstraction layer to work with the hardware, and higher layers like the user interface and the application are built on top. Booting is the operation of starting the operating system on the computing platform. This term comes from pulling oneself up by your bootstraps. Early bootstrap loaders would write over themselves, which reminded early programmers of pulling yourself up by your bootstraps. The bootloader starts at power up or at reset. It then loads and starts the operating system, and the operating system can then start applications. Many operating systems use a timer to manage the execution of multiple programs in the operating system. In this case, the timer interrupts periodically and tells the kernel to look at who's running. First, the A program is running. Then the kernel decides to stop A and cause B to run, and then C is allowed to run. Scheduling determines the order in which programs are executed on the CPU under the control of the operating system. Many operating systems use priorities to help determine which program will run next. A static priority or fixed priority system does not change the priority of a program during its execution. A dynamic priority system can change the priority of a program as it executes. The priority of a program could go up, making it more likely that it executes, or the priority could go down, meaning that it's less likely that it will execute. Context switching moves information about the execution of a program into and out of the CPU. We context switch in order to move from one program to another. Preemption stops the execution of a program so that the operating system can switch contexts to another program. Not all operating systems use preemption. Some operating systems use cooperative multitasking, in which programs voluntarily give up the CPU and return to the operating system. A file is a fundamental abstraction of data in the computer system. Files are maintained on a storage device. The file system provides important abstractions that simplify how users can manipulate data. Here's a simple example of a file that contains some characters that spell out one sentence. The file system keeps track of the name of the file. It also keeps track of the data in the file. In this case, the file system has divided the characters in that sentence into 3 pieces and stored them in separate parts of the storage device. The file system records segment 0, segment 1, and segment 2. For example, segment 0 records the first part of the sentence, the quick brown fox. Segment 1 records the second part, jumps over thee, and segment 2 records the third part, lazy dog. These segments can be kept in different parts of the storage device. They don't have to be recorded in a single string as they appear to be to the user. The file system manages access to this data such that the characters come out in the order in which the user expects them. This distinction between the data and how it's stored on the device makes it easier to modify the file. In this case, we change several characters in the string from the quick brown fox jumps over the lazy dog to the quick brown fox surprises the watchful dog. We don't have to change all the bytes in the file in order to accommodate certain changes. When we look at how the file is stored, the first segment stays. The second segment changes. It's deleted and then replaced with some of the new words. The last segment is also deleted and replaced with the rest of the new text. Directories help users keep track of files. A directory maintains a set of files. For example, in this case, the directory C holds typing.txt. A directory can also be contained in other directories. For example, the directory C is contained in the directory B, and the directory A contains both B and the directory D. We use a special directory, the root, in order to tell us where to start searching for directories that may have files that interest us. Device drivers help applications and operating systems work with I/O devices. In this case, the application wants to use a device. It talks to the driver, which then talks to the device. The result is then sent back. Many hardware platforms provide several different modes of execution to help maintain security of the computer system. So an application may run in a user mode that allows it to perform basic operations, but not certain other things such as directly talking to I/O devices. If the application wants to perform a privileged operation, it will ask the operating system, which will then execute and return the result to the application. An exception is an unexpected condition during execution. A hardware error, for example, or division of a value by 0. A trap is a mechanism to respond to exceptions. It changes the program flow in order to execute a handler devoted to that type of trap. In this case, the application performs an operation that causes an exception. The operating system vectors the trap to determine which handler should be called. The handler performs the operation, returns to the operating system, which can then return to the application. The desktop metaphor is used by many computer systems to organize how users work with the computer. The desktop metaphor organizes the programs and data on a desktop. The user can then perform familiar operations, like on a desktop. A common organization for the desktop metaphor is known as the WIMP model. Windows provide user interaction spaces. Icons identify programs and data. Menus allow the user to select operations to perform, and pointers allow the user to select icons, menus, and windows. Here's a simple desktop with two windows open. One of them is an application. The other is a view into the file system. You can also see that there's an icon on the desktop. This window shows one of the directories in the file system. That directory itself has two subdirectories. This window provides a prompt. The user can type commands into the prompt and execute them. Thanks for watching.